Um, Hi everyone. This is also kind of random stream. I just thought 15 minutes ago to make a video on this. Let me create a text file so that we can share it and start seeing that. There should be something to find these folders easily. Okay, not desktop. Which was which was stream. Uh, Today's date is June 7, 2026. Let me open that in a VS Code window. Yeah. Let me keep it behind this so that. Yeah, I think we're ready. Let's start it. Sharing my screen. Visible, yeah. So the topic for today is oh, okay. The topic for today I thought is why DSA, uh, real world use cases of DSA. Why interviews are on DSA, but work is no way. But actual work is no way related to that. Yeah, I'll cover these three topics. The second topic is pretty much wider, and yeah, there'll be interesting cases that I read about in this 1.5 year since Jan 2025. Yeah, so why DSA? Like, okay, I think okay, now ordering of this might be changed. I think first we should discuss about second point, then we should come out first point. So let's see some real world use cases of data structures. First one I could think of is Google Maps. For this case, maps usage maybe. Yeah, like for example, Google Maps, Uber, Rapido, all that stuff. So let me come here, create a survey draw file. Just now I took a head bath, so my hair is pretty good. Yeah. How to write here? Okay. Uh, Maps. When I say maps, it's for navigation. So this is not a navigation hasn't come when Google Maps or Google came. So basically, this was a problem with the birth of internet. When uh, when you are communicating between system A and system B, the packets of information has to reach from one place to another place uh, via all seven layers of the network layers that we have. So in that, our routers plays an important role. So routing IP packets so that distance traveled is minimized. So, so imagine there is a router A and there is router B, and router A has to send that packet to router B, and there are multiple hundreds of routers in router B. If router A takes all the different paths, so it's the time of communication will increase, right? Because it's taking the longer path. There it has to take shortest path out of all available paths. And how many paths are available? It depends on how many routers are there. Let's consider it very huge. Like if you consider internet now, it's it's very vast than we can imagine. If you go back to the time where it all started, so that time maybe you can say some you I cannot say number, but it's less. So out of all that available uh, immediate intermediate routers, your router has to send packet to its nearest router, and this router has to send to it nearest, so that entire path from router A to router B is minimized. And if you see the permutation and combination, which I'm pretty bad at, but yeah, if you see, there is a route where I can I draw freely. Like, this is exactly maybe notepad also I'll open. Scratchpad, not notepad. Yeah. Okay. Got it. So let's say there is one router, and this is this router, and this is router B. This is R1. This is R2. Wait, let me draw it like a R. Yeah, R1, R2. So there is a path here. Why is this pen is so weird? I'll take pencil. If there is this path, and from this here, 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 and from here, here, here. Let me highlight the routers a bit. Uh, okay. So I think yeah, it's understandable kind of. Yeah. So so R1, okay, this is also connected to this. So it's a complete graph where there are so many possibilities. Router can send it to these three connected nodes, and each connected node can send to any of the node. So you can it's basically the sum of what are the possibilities, number of paths, number of distinct paths can exist in this. That's a very good graph question. But yeah, let's not go into that. Number of distinct paths can it, because all this has the degree, sum of all the degrees. It's the different ways that it can route. So you can write the possibilities on pen and paper, using pen and paper. So it is many. And how how does that happen so fast? Because the moment I am typing a message and you all are seeing it live, or the moment I send a message to my friend is somewhere in hundreds or thousands of kilometers away, and he's seeing that message instantly. How that happens that quickly? That is because if that happens that fast, if that data transfer, this which is part of it should happen faster than what, maybe one tenth of a fraction of what the entire thing takes place. So yeah, here it's used. That is where shortest path comes in. So Dijkstra and many other scientists has, it's their lifetime investment, right? So they spent around exploring all this, and yeah, so this is where they can do that. So that is how Google Maps, when you type, when you want to go from Bengaluru to Hampi, for each intersection of a road, it's a node, and there will be some hundreds and thousands of that intersection. If you try to find a path from each intersection, what's the shortest path, that's like a mess. So but it suggests you the, but it suggests you the shortest path of that. And that is how, what that's what happening beside behind, it's just graphs and graphs and shortest path algorithms. Here I can tell navigation rather than, okay, this is a little bit, I don't, most of us might be knowing this, but if somebody is new, didn't expect that databases has data structure inside that, it's fine. So, so not only about so okay, you take any database, what does a database do? So let me start again here. Storage and retrieval. Yeah, what does database do? Stores data and retrieve data on requirement. So but how does so so if you take, so if any database you interact with it using the specific um, data definition language, for example in SQL select star, using that, this that, and same way with delete and stuff. But how does that, the insert, the data that you are inserting and going and sitting into disk, how does that spread over there for fast retrieval? How does that search across multiple rows or whatever records that you call happens that quicker? Because internally it uses different trees based on how, right now they are using self balanced trees or BST trees, not BST. One second. So each node represents a row, and based on your query, the for the quicker retrieval, the remaining nodes will be ignored, and you'll get the specific one as a result. Each database has its own implementation, like Postgres, MongoDB, Elasticsearch, or whatever, MySQL. Um, all they have different data structures behind that. So basically it's a trees, but not simple binary trees. They are more sophisticated, um, balanced self-balanced, and all the different trees, right? So not simple binary trees or binary search trees. The third one is text editors. What do you mean by text editors? uh, VS Code is a text editor. VS Code, any ID, If you are using Mac, Apple Notes, Notepad, so on, wherever you can write text and that gets saved in your laptop, and when you open that again it's shown, that's called as text editor. And you can edit or you can write in that, in those. So text editors, these are text editors. So imagine, right? So whatever you are seeing here on the screen, so where does, if, even if I close this now and if I open it, this will be saved in this file. So basically I'm editing this file which is stored on the disk. How does that happen so seamlessly? Like for example, I can do all enter here and I can write some random text here. I can do this. And if I save, if I close this, if I open again, it happens here. So how does this is so seamless? Like how does this happen? Have you ever thought about this? So for example, you think that whatever is happening here, for example, it's a string. So what are advantages? Maybe like because you're appending characters at the end of the day, right? Think it's a string. It's a S0, S1, S2, and so on. Wherever line breaks, you can increment the index and stuff like that. Why does what's the problem with string? Insertions are costly. For example, if you are writing a line and if you have written the 100 words in that, and inserting in 50th word, you have to move all the next 50 words next to one shift and you have to insert there. That's a costly operation. And that's not only cost in terms of time, in terms of memory also, because you have to reallocate the initial memory and do based on that. So now famous libraries from C++, STL, and Java collection framework, they have these data structures which expands based on the size. But behind the hood, they also does that calloc malloc, like you clear the memory for current thing and create memory for new character limit or whatever. So what does this text editors use? So for example, have you ever noticed that, I don't know how many of you noticed, but Apple Notes sometimes get stuck because if you had too much information, if you scroll a little bit fast, like that, in that case, let me show you an example. um, okay, one of the blog that I was written, this is normal basic text edit application, so it's pretty fast. But in Notes, if I keep scrolling like that, you see glitch in between the information that you see. And if I do multiple copy paste, so let's say if I click enter here and if I do something paste, that's it. It'll take little bit slow to adjust the information. That's because the data structures used to store that information, when retrieving it, not, it might not be that fast. And here also it's trees. I don't know the name, but yeah, it's just not, it's also not normal tree, some specialized tree. uh, this also use specialized trees. Okay, Google Maps navigation, databases, text editors. So in databases, you cover something like um, SQL is a language. Okay, SQL databases, you can tell that's a confusion. Postgres, whatnot, so many. So almost all the databases has to use some of the data structures to store the data efficiently. There's a blog on this from a employee from Stripe. If you are interested, I'll attach it in the comments. Read it. What are the data structures behind text editors? How does it evolve from plain strings to the uh, whatever the latest trees that they were using? And yeah, I think most of the use cases are covered. Okay, why not? Why to leave agents? Agents, I mean, Langraph. graph data structure to create workflows for LLMs. So, for example, it's a decision based. Once you receive the question based on the system prompt, act according, go to the specific path. If the question is regarding this, go to this node and execute the particular function, get the output. With that output, if this output contain this, go to this. So it's basically like a flow like this. So these are directed. It can be many, right? Just I'm just saying the directed. Let's not confuse this. So yeah, so at node one, if you come based on that, execute this function. So you take this path, then you take this path, then whatever the decision you make here, come to this path. So it's like that. For example, in this case, take this path, go here, then again, if you get something from here, so they can again go to this node, so again do something here. So it's basically it's creating workflows. So Angular and yeah, this graph data structure with Langgraph and stuff. Again, when I say databases, all this Redis and all the stuff comes to store data efficiently. And what else? What else I can think of? Git version control system. Git internally uses trees to keep track of the versions. So if you would have given the Git task to any of the agentic IDE and to pull or review the changes and stash some changes, it keeps doing that because uh, it also trees use in trees for keeping track of version control. So how do you see that, like, okay, for example, there is a main branch here, there's a main branch, and you have, okay, so this is a main branch, and there is a user 1 and user 2 who has kept changing things for their branches. Again, user 2 has done some more changes. User 1 has committed, user 2 has committed, and just a second. Hello. Um, yeah, sorry, my somebody. Yeah, I had to go. I got some parcel. So yeah, where were we? Yeah, for Git uses trees for keeping track of the version control, and I think you know this better. Like, how does it how do it detects merge conflicts, and how does it compares two changes? So all this is powered by wonderful trees. And again, those are also not simple trees. Some uh, very depth or something like that. Very depth trees. So the next one is, what can I think of? What can I think of? There are so many, right? Because all the whatever daily you are working, some of this comes under this. For example, daily life usage or text editors. I think every software engineer will write code somewhere and keep pasting random things, and it's very optimal. It's very fast, very quick, because all this agentic IDs also edit your codes and stuff. Langgraph agents again to decide workflows. Git again. Every software engineer would have seen this. And what else? What else? What else? Okay. Music apps. Very interesting one. So we have a set of songs that, let's say if you are listening to a song and the vibe of that song is good, and you want to add similar, you want to play, you cannot keep on for every song keep on changing, right? So you add songs in a queue, so that after this next song will play, after this next song will play. It's like that. When you add a new song, and that song will go and sit on a for example, like this. So let's say there is one queue like this. Okay. How did it is? Oh, okay. Sorry. My bad. It is okay. This is a queue, and this is a song one. After that, you added song two. After that, you added song three. After that, you added song four. Then song one finished. Pointer will be here. Song 2 will be playing. When song 2 finish, pointer will move here, and like that. When you add a new song, that will come here, somewhere here. So it's a queue, right? You are adding a songs or keeping songs in a queue, so that it keeps adding from one more side. Oh, my bad. I had to, yeah. Yeah, add songs in queue, music apps. Seventh one, Google Chrome. So if I open a new tab, for example, my LinkedIn, and I scrolled it, I used it for some time, and I closed it. And now, if I want to open it again, if I do Command Shift T, it opens. And if I do Command Shift T, it opens some other page that I closed just now. If I do Command Shift T, it opens the website which I opened before opening this website. So how is it happening? So where do I draw this? Why is it? Okay, let me go to a new one. Huh. So say this is my stack, and all the closed websites will go here. Let's say I closed W1 first, then I closed W2 next, then I closed W3. So now ideally, okay, let's do something. Let's open first LinkedIn. close it, then open YouTube, close it, then open lead code, close it. And now if I do command shift T, it opens lead code. After this, if I do command shift T, it opens YouTube. After this, if I do LinkedIn, it opens this. So the latest, the last website that you open, and if you do command shift T, it's coming this, next this, next this. So it's like last in first out, which is stack. That's how browser keeps track of your closed tabs, so that it can open very quickly. No need to ping again that page and get that state of that page will be saved in stack, so that whenever you do undo, it comes. Yeah. mm, Undo of tabs. um Scratchpad, not scratchpad, what is it called as? Okay, let's see. Control C, Control V. So it's like that. Again, this also same thing. When you copy something, for example, so let's say if I copy this line and I paste it, and again if I copy this line, if I paste it, so now next time if I paste, the same one that I previously copied comes. That is because again it's a stack. So it's a stack. So first I copied sentence 1. Control C, if you do, it triggers this. And when you do Control V, the stack top will be popped and will be pasted at your starting from your cursor. And this movement of the deletion from stack doesn't happen until you clear your clipboard. So after pasting S2 for multiple times here, say when I copy this thing, this line, these 2 lines, if I paste it, all these 2 lines keep repeating. That's because when I selected something and do Control C, some new text block would have come here from named as S3, and the pointer will be closed and will be pointing to this. When I do Control V, this will be coming out. So clipboard uses stack to keep track of CTRL-V and CTRL-C. Here also it uses stacks. And if the number goes, the number keep going like that. For example, task scheduler in CPU, it's a queue, and rate limiting any time if multiple requests come to the server, and where are these requests will be kept, all the requests will be waiting in a queue, so that the first one who came would be taking this. Same with the multi-threading. All this is data structures. So if we keep going like this, you keep observing these numbers will increase, maybe till go to some 50 or more than that. Behind any tool that you use or any technology that you use, if you deep dive into that, at the end you find is data structures and algorithms. Take anything, database, Kafka, Redis, caching techniques, network protocols, streaming, whatnot. Everything and anything at the root level is data structures and algorithms. Level is DSA. That's why companies are, for example, okay. Now we discussed so many things, right? The real world use case of DSA like that. See, now you will be having an idea of how to view this behind what what does you have that, how do I, you will connect the dots now. For example, when I now, since you know all the information, you start thinking, take some random technology. How does, for example, my laptop keeps track of the closed applications or tabs? Some data structure will be there to store that information. So in my previous video, I told, the basic principles from where all the softwares have evolved. There I mentioned three things about data. What you can do with data. One is storage, one is movement in the sense data transfer. Third one is computation. When the term comes storage, databases, caches, all these are comes into picture, and under the hood, it's, um, uh, under the hood, it's again data structures. When the point comes to transfer, again communication protocols, routers, routing algorithms, IP packets, algorithm, shortest route. Computation, you write some algorithms to compute the stuff efficiently. How do you compute, things coming from a stream of data? How do you get, how do you do operations on incoming stream of data? It's algorithms. So you keep importing stuff from Python packages, for example machine learning libraries, all that, algorithms, random forest, decision trees, all these trees, algorithms. So at the end, what I want to say is, everything and anything that you see in software at root level is either powered by data structure or it's an algorithm. That's the reality. So why do companies ask or expect DSA? And it's there are some specific criteria or specific set of evaluation that you should evaluate candidate on. Let's say 3 rounds or 2 rounds. Say he's from Java background and you are, the interviewer is from Python background. What you can ask? You cannot ask Java because you are working on Python. He cannot answer because he's not worked on Python. But that doesn't mean that that candidate should not be hired. You have to evaluate on some terms, right? So at least this will occupy 1 or 2 rounds of evaluation criteria. That's why still people believe that people who are not good at this doesn't mean they're not good candidates. I agree with, not everybody needs to be good at DSA, and very few are very comfortable and good going with DSA. Some doesn't feel like, why are we doing this, if not using at work. You ask me graph travels algorithm questions, Bellman fold algorithm in interviews, and what I do in the work is UI, React framework. I use React and I build UI. There is no a single connection or match to that. How does that, why does that matter? Why do you need to know about data structures and things? So the point where, why DSA comes to, from, I'll write this in caps, builder. When you build something, when you create something, when you invent something from the zero level, ground zero level, for example a library or a package or a framework, you have to use some data structures or algorithms in order to get the functionality to that library or package. When you build, when you are creating your own databases, when you are writing your own logic for information retrieval in your own search engine that your team built internally, or when you want to launch one more Git version control which has more features than Git, again you have to use this. When you want to, the knowledge of switching, choosing databases in different scenarios, you should know. For the trade-offs, you should know data structures. How does it working internally, something like that. When you are building something, you need DSA. How does Uber finds quickly allots you to nearest drivers? For example, you are here. Let me decrease the font color. You are here, and driver 1 is here, driver 2 is here, driver 3 is here, and driver 4 is here, driver 5 is here, driver 6 is here, driver 7 is somewhere here. Now, as a user, you are here. US, this is E. As a user, when you start booking this, how does this is a functionality requirement? Uber matlab, user go select pickup location and drop location. When you click on book now, all the drivers should get notified. So among these, which driver should get notified? Among D1 to D7, is it D7? Is it possible? What is it the optimal way for reducing time of user, wait time of user? D3 should go or D7 should go? D3 should go because he is the nearest to this. Among all this random, it's a real world map, right? How do you select the distance between these three? You cannot tell that, I can keep these as a nodes. Consider each driver as a node, and you find shortest path, like from a single point to a shortest node. Like it's a point to destination algorithm. There is one name for that. I'm not currently remembering it, but yeah, you cannot say that because if you consider this as a node, this node will be after 5 seconds it will be here, and this edge weight has to be updated. That's a complete mess. So what they do is they kind of divides the space around you into a hexagon. Sorry, my bad. See, Control Z, it's gone. Undo, redo, it's again stack. Yeah, this is hexagon. Hexagon again. This also hexagon. Yeah, it's like that. And they kind of calculate distance from center to each driver in that particular hexagon, and they use that. That's their approach, and they found it super useful, super optimal. That's why millions of users entire world are using this, and for each user this should happen on the fly means algorithms, nothing else, nothing other than that. When imagine you are being hired as a founding engineer or some member or architect in this team who are designing Uber maps, obviously you should know this algorithms which to use based on the use case and requirements. And at scale, how does that happen? Choices should change between when the scale comes because the trade off changes. So yeah, when you're building something, you have to use that. But other than if you are doing a typical software engineering job like in a MNC, you don't get to work with the product this closely until and unless your team come up with something, a new product or something, and you won't get to work on that, and you will not understand the importance of data structures and algorithms. Yeah, ultimately I want to say is we answered this, and we answered this, and we also answered this. And yeah, one more thing, one new thing I wanted to say. GPS, how do you say you enter your latitude longitude, and how do you wait, let me open a new one. This is a new one, no? This is a new one. So if you have a latitude longitude something like 51.0 random number comma minus 56 point again random number. Why should not be there? Sorry. Yeah, this is a point that okay. This is a point that you have to locate in x and y axis. So ideally, let's draw the line. So what you do, it's plus 51. Go here, 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 here. Here is plus 51, and it's minus 56. Go down, down, down. Minus 56. Mark this point. What is the complexity of this? It's m plus n. What if? How do you keep track of this changing on the dynamics? Because latitude and longitude coordinates changes in within time if it's a moving object. You cannot do keep track of this for every movement. It's unoptimal. How does it happen? How do you locate this? Again, it's a tree. So it's a BKD tree where the entire region is, can imagine like a 2D plane. So when you say 51, this left part of this is excluded, and this entire part is excluded for navigation. When you say minus 56, this entirely is navigated. So they do with the complexity of big O of m plus 1, log of m plus n, instead of uh, big O of m plus n, which is very super unoptimal, that they change to big O of log of m plus n. Yeah, this is the optimization that they can do, so that they'll keep track of your GPS moving here and there. For example, how does all this live location tracker, you are sharing live location in WhatsApp, your friend can see the thing that you are moving, and similarly you can see a Rapido delivery person coming to your location, and that happens on the fly. That keep if he keeps moving, that maps keep updating, because yeah, all this. Nice point, we can add it here. I got remember. If you want to build GPS tracker, so yeah, you can come up with a new tree or new algorithm that does in within less than this time. BKD trees. And yeah, if you keep thinking like this, hundreds of things will come, as I said. And yeah, I think we answered all these three questions. And yeah, like now I think people are, you should know why data structure and algorithms matters. And if you are not working on data structures and algorithms or close to products, that doesn't mean they are not required in software engineering. I hear a lot of people saying this, इंटरव्यू में 3-4 राउंड में ग्राफ्स ट्रीज लिंक्ड लिस्ट वगैरह पूछते हैं. फिर लिंक्ड लिस्ट आई नेवर रिवर, आई दिस अ मीम, दिस अ रील्स, राइट? इट्स लाइक you never in they say in my 10 years of experience I never reverse the linked list, because that's all been done under the hood for you. Why do you you are not doing it? Because that's already done for you. If that use case comes, you have to definitely do it. And yeah, that's the all for this stream. And I think we are, oh, it's almost 1 hour. Every time I think to cut time, but I don't know, it naturally goes. But yeah, dinner time, ending my stream. See you in the next one. Bye.